Excellent. Okay. Well, welcome everybody. It's my great pleasure, honour to introduce William Gray. It doesn't really need any introduction. He's a honorary researcher here at UQ and was and has been a colleague for many years. And he's going to be giving us a talk today on carbon net zero, the physics, chemistry and politics of carbon and its implications for the human future, if there is one. That class. Okay.
Okay. Right. Well, predicting the end of the world is a thankless task. You can be proved wrong many times, exposing yourself to derision, but nobody's going to applaud when you get it right. Anyway, climate certainly presents us with a lot of serious problems closely associated with carbon. Life consists of interconnected and interdependent carbon structures, continuously exchanging chemical constituents through networks by very intricate carbon chemistry, which is maintained and activated by the solar flux of our local old main sequence star, the Sun. And the Sun is a third-generation star formed from a nebula enriched by elements produced by nuclear synthesis in previous generations of stars. So, not getting anywhere. Will I use the...
Try now.
Yeah. Good. Carbon was absent in the early universe. It formed with the so-called triple alpha process, which takes place in collapsing supernovas. These stars burn for probably 1 billion or 2 years and then collapse, generating more energy in their collapse than our Sun will in its 10 billion year history or lifetime. Most carbon is produced in the final second of supernova collapse. So much of the material of which we're all constituted started with a bang, actually lots of bangs, because there are, this is a nice periodic table that indicates the sort of star in which your constituents might have been formed. So carbon seems to be mainly from low mass stars collapsing, but we all have some iodine in it, and that's an important chemical for us, the thyroids, and that's probably the result of a collision of 2 neutron stars. Anyway, there's a wonderful parade of nuclear synthesis from all sorts of exciting stellar events that have all contributed to each of our constitutions. Carbon has a unique capacity for covalent chemical bonding, and it can share electrons with an enormous range of materials, metal, non-metal, as well as with other carbon atoms to form chains, loops of intricate shapes and not rigid stability, but they are stable enough. Over the 3 billion years of evolution, carbon structures and carbon chemistry eventually evolved structures with self-conscious intelligence, which includes the power to understand some of the processes which enabled their emergence. It's been said that a physicist is an atom's way of detecting another atom, and perhaps we could add that self-conscious intelligence is the means by which the universe achieves some rudimentary self-understanding. We are bits of the universe which have achieved limited self-understanding, as well as limited understanding of some other bits of the universe which constitute the structures and processes from which we've emerged. So here we are, life, mainly water and long-chain carbon molecules, stardust, the debris of exploded stars. And we're here because the chemical processes that enabled the emergence of increasingly complex structure over a period of about 4 billion years, the differential survival of self-replicating molecules has generated the disparate lineages which collectively constitute the biosphere. Processes which are possible because of the unique properties of carbon and its favourable situation with respect to the energy flux of a star. Well, like other organisms, the favourable conditions are, first of all, you have to be in the galaxy in a Goldilocks zone, which is about 23 to 30,000 light years from the centre. If you're too close to the centre, then there's too much activity going on. So it's unlikely you would have a few peaceful billions of years in which life could emerge. Further out, beyond the 30,000 kilometres, there is not enough metals, not enough carbon. So that's the interesting spot. And within the solar system itself, there's also a Goldilocks zone somewhere between the orbit of Venus and the orbit of Mars. So you've got to have conditions set favourably in order for the interesting chemistry from which we are constituted to emerge. Our galaxy has 100 billion stars. That's a lot of real estate, but probably not enough real estate to make the existence of other technical civilizations at all likely. The likelihood of being contacted by extraterrestrials is infinitesimally small. Mind you, it's possible, quite possible we're the only intelligent life in the galaxy, but since the universe is 93 billion light years across and has trillions of galaxies in that inconceivable vastness, it's very likely that there are other systems. It's just that they are permanently causally isolated. So we're not going to get any extraterrestrial visitors anytime soon. Okay, organisms are somatic problem solvers. Sequential problem solving involves the process of problem solving drives the evolutionary process by which the increasingly complex structures have developed progressively from amoebas all the way up to Albert Einstein. Well, what problems do amoebas solve? Well, the basic problem faced by any organism is the existential problem of survival. How to find dinner without becoming dinner for somebody else. In the restaurant of the biosphere, everyone is both at the table and on the menu. The trick is to spend as much time as you can at the table before you become, as inevitably you will, an item on the menu. Now, organisms have developed many strategies for staying at the table and off the menu with exosomatic structures, honeycombs, webs, dams, nests. These are endosomatic organs. Cooperative collective structures help creatures to survive, to prosper, and to flourish in our pitiless and unforgiving world. One amazing development has been the development of neural nets by which organisms develop awareness of their environment together with the capacity to respond to it. This is a form of early proto-awareness. It's not working as it should, but I was trying to get a star anemone up. Yeah, there it is. This is one of the oldest creatures still extant that has a functioning neural net. And interestingly, it's got a lateralization because nets and any kind of nervous system has two important tasks to attend to. One is vigilant awareness, to keep an eye out for opportunities or threats, but the other is to have some focused attention so you can take advantage of opportunities or take evasive action if required. The brain we've inherited has been adaptively shaped as an evolution, by evolution, as an instrument for survival. That is, for staying at the table and off the menu. If we jump forward 500 million years, neural nets have morphed into central nervous systems of staggering complexity, culminating in our hominid brain. which has quadrupled in size in the last million or so years. I read in a bit of research just yesterday, which I'll have to follow up, that the brain has actually got smaller in the last 3,000 years, and that's an intriguing fact that I'd like to find out a bit more about. After all this heroic expansion, it's decided it's gone far enough and we're starting to retreat. Anyway, the human brain has developed a unique structure which helps us to survive and to prosper. It's not an exosomatic structure like a honeycomb or a termite nest, but a unique socially shared cognitive resource, an endosomatic structure which provides the capacity for abstract representational thinking. Representation and representational thought is the product of a modified, expanded, repurposed left cerebral hemisphere, where these abstract representational structures, maths, logic, and the natural languages, they're all domiciled, at least a lot of them are. Well, there are other parts handled elsewhere. The cognitive power of the left hemisphere has been powerfully amplified by exosomatic prosthetic cognitive devices such as books, hard drives, smartphones, pocket calculators, GPS navigation, all the plethora of digital devices that increasingly enshitify our lives. On a larger scale, there are more remarkable prosthetic devices like the Large Hadron Collider, the James Webb Telescope, and the explosively developing tool of the hyperscalers, the large language models of artificial intelligence. Okay, well, that's the kind of background for artificial intelligence. I came across that little indication, which I thought was a nice comment. Carbon plays a vital role in maintaining favourable conditions for life, such as stable temperature, and it has done so for billions of years of geological time. The atmosphere is transparent to short-wave solar radiation. Not going in order. And conditions such as stable temperatures have been maintained for billions of years by modulating it with various products, and carbon dioxide is an important molecule for maintaining that stability. The atmosphere is transparent to sorry about this. I think this somehow got scrambled.
Do you want a hand?
I'll try doing it with. No,
What are you trying to do?
I'm just trying to change the slides.
Backwards and forwards keys, left and right.
Yeah.
Keys, arrows.
That one?
Yeah, okay. They're not coming out in the right order. That's what's frustrating me. Okay, well, this is an illustration of the solar radiation coming in with shortwave insulation, which penetrates the atmosphere, warms the earth and the oceans, and that is balanced by outgoing infrared radiation, and it's the balance of some of the heat, or some of the energy coming in being balanced by heat going out, but some of it is trapped by the greenhouse gases and reflected back, and it's just as well that it is, because otherwise the temperature of the planet would be, I think, about -16. Now, this process of maintaining some kind of temperature balance for the last 800,000 years, you can see there, has fluctuated between on the top between about 180 and 280 parts per million. That's 0.028 or 0.028 or 0.03 roughly. Is that working? Okay.
Yeah, if you go to more on the far right, you can find high floating meeting controls.
High floating this. Okay.
So for pretty much all of the evolutionary time in which we have developed, there has been a fluctuation between about 180 parts per million and 280 parts per million. And what's happening now is we are starting to go wildly outside this familiar range to which we are adapted. The last glacial maximum was about 26,000 years ago, and CO2 was about 180 parts per million. And the mean temperature was about 6 degrees cooler. And at the present level, it's about 420 and rising. We've raised the temperature so far about 1.4 degrees, and it's going to keep on going up. Some carbon certainly is needed. Up to about 350 parts per million is very welcome, but beyond that, it's too much of a good thing. And there is certainly acknowledged by climate experts an urgent need to reduce fossil carbon emissions because they are going to head us towards temperature rises of 2 to 3 degrees unless we act very swiftly. The effects of adding carbon dioxide to the atmosphere have been understood for many years. Indeed, the Swedish chemist Svante Arrhenius in 1896 calculated that doubling atmospheric carbon dioxide would raise the global temperature about 5 degrees. And he thought, living in Sweden, that would be an excellent thing to do. But it's at least 40 years since we've had active voices urging caution. James Hansen was one of the early ones, and about in the late 1980s. And 20 years ago, Al Gore set up the what's called the Climate Project at
If you just use the mouse to click on the screen, anywhere on the screen, that should get you back into use the mouse.
Yeah. Yes.
Oh, I see. I'm just on the screen there.
Yeah, but turn it around with.
Ah,
Yeah.
okay, good.
Just click once, and then you should be able to use the arrows again.
Yeah. Okay, that's just illustrating the importance of carbon dioxide, looking at the inner planets. Venus has a surface temperature close to 500 degrees. We're at the Goldilocks level 15, and Mars is about -50. But Venus is a lot hotter than Mercury. In fact, that's because it's got a strong carbon dioxide atmosphere. It gets a lot of greenhouse warming. And the Moon, -23, that indicates, because that's about the same distance from the Sun. So if we didn't have any atmosphere, then the surface temperature would be somewhere down in that region. I think it's about -18. Here's what's been happening with the addition of atmospheric carbon over the last almost 70 years nearly. I think that's when the measurements were started at Mauna Loa in Hawaii. And you'll notice that there is no sign of any slackening as we go from, well, the first warnings about the need to reduce emissions started about here. When we get to about 2000, then the voices become a little bit more urgent and say, unless we start hitting the peak by 2010 and 2015 and bringing them down, we're in trouble. And anyway, it's had pretty much no effect on moderating carbon at all. And this is looking at a longer period. We can see the accumulation of carbon dioxide as the fossil fuels are burnt. Well, things are getting a lot hotter now. And if we look at the hottest, I think I checked that the 25 hottest years since 2000, 24 of them are in this century. So there's certainly no indication, likelihood of heading down. But Al Gore's climate project, which trained number of volunteers as climate project presenters, and there's my Al Gore badge somewhere here. We have made very little impact. An Australian Bureau of Statistics survey in 2008 showed 73% of Australians were concerned about climate change. By 2011, it had fallen to 57%, and turns out it's remained round about this level ever since. So we have the rather discouraging fact that as emissions have increased, concern about them has diminished. Al Gore said, when you give a climate talk, which I guess this is a bit of a climate talk, you have three budgets that you need to respect. There's the time budget, the complexity budget, and the hope budget. And I hope I can more or less respect all of those. But there's a serious problem to be addressed. Mean surface temperature and carbon dioxide are rising in lockstep. If we take a base of average temperatures between 1960 and 1990, the last cooler than average month was February 1985. So in March 2026, we've had 494 consecutive months of above average temperatures based on that particular period. My daughter Rebecca, born in 1985, has never experienced a cooler than average month. And about 3.5 billion humans, or 43% of people now, have not experienced a cooler than average month. So atmospheric carbon pollution is certainly happening, and it's creating a cascade of consequences that will seriously reduce the planet's carrying capacity for humans as well as for our companion lineages. So what about replacement with energy alternatives? It turns out to be technologically, economically, and politically very difficult. Oil is an absolutely wonderful energy source. 1 barrel of oil provides energy equivalent of 24,000 hours of human labour. So global fossil fuel use is equivalent of about 800 billion humans working an 8-hour day. A human adult can expend about 100 kilowatt hours of energy in a year. A litre of petrol is equivalent to 1 year of digging by a human. So, and if you wonder about the equivalence or the power of petrol, if you've ever had a car that's conked out and you've had to get some friends to push it up a hill, you appreciate just how much petrol is able to sort of provide an intensity of energy that is certainly something that we find very agreeable. And the lifestyle of industrial consumers, the food, shelter, health, transport, is all underpinned by energy, 80% of which comes from fossil fuels. But we live in a hydrocarbon society which is coming to an end. The fossil fuels are a non-renewable resource, so they have to run out sometime. If we let them run out, then the planet that is left at the end of it is going to be disagreeable in a number of ways. A cascade of consequences has already been set in train by fossil carbon. Now, Jim Bendel has written a book on societal collapse. And in fact, he's not the only one. There's a nice book by David Wallace Wells called The Uninhabitable Earth. Joel Gurgis, Australian, has also got a book on it. So there's plenty of writing out there on this topic. But Bendel, I think, writes very thoughtfully and interestingly about it. Energy is the root cause of many deepening and intractable social problems. And most of this energy is in fossil fuels, for which we have a powerful social addiction. So lifestyle of industrial consumer societies, food, shelter, health, is underpinned by energy, and can't work out what's going on. Quote from Bendel, we are witnessing the beginning of an ending of industrial consumer modes of sustenance, shelter, health, security, pleasure, identity, and meaning. So he thinks that there is kind of systematic social breakdown going on already, and you just have to look around at what's happening to see that this hypothesis kind of explains, perhaps, or gives a framework for making sense of the book. Breaking Together is available online fairly easily on the internet if you want to have a look at it. Now, collapse isn't a single spectacular catastrophic event. It is a slow, inexorable process. Bendel believes dominant systems of communication and powerful institutions, the hyperscalers perhaps, permit or even encourage dysfunctional human behaviour. And they successfully manage to not stifle, but somehow sidetrack talk about the need to reduce carbon emissions. Certainly, there's a lot of talk by the Labor Party, which I'll mention in a moment, about the need to reduce, and we've got a so-called policy of net zero by 2050, but nothing is matched by any serious action. A week ago, we were using 100 million barrels of oil per day. With the closure of the Strait of Hormuz, it's reduced by about 20 million barrels per day, down to about 80 million. Now, this is a nice depiction, long-term perspective on fossil fuel consumption. It was devised by M. King Hubbert, who was a geophysicist with Shell way back in the 1950s and 60s, but he said that the fossil fuel period would be of a very short duration. And this chart depicts, and we are at the moment pretty much sitting at the top of that, or slightly over the top. We've entered the downward slope. And the carbon dioxide, nevertheless, is showing no sign of declining whatsoever. It's still holding up. The last 250 years since the serious use of coal began, we've added about 680 to 820 gigatons of carbon. That's 820,000 million tons, and about 380 of it, almost half the carbon that has ever been emitted has been released since 2015. That is, since people have been calling most of the time politely for some policies to try and mitigate or slow this process down. It's just politically and economically intractable. This is an interesting bit of paleoclimate history, looking back in the geological record. There's one item on the top left, you'll see PETM. That's the Paleocene-Eocene thermal maximum. It's a spike that goes up 55 million years ago when a lot of carbon was pumped into the atmosphere, possibly volcanically. But it does give climate scientists a kind of a model to think about substantial changes in the surface temperature. But what's a bit worrying about it, the Paleocene-Eocene process is the blue line. So it went up 8 degrees, but over about 20 millennia. So it was going up 1 degree every 2 millennia, whereas the red one is what we're at the moment, going up at the moment, it's probably as fast as it's going to get, but I think it's about 1 degree every 2 decades at the moment, which is, I would think, temperature change of that magnitude probably couldn't be found anywhere in the geological record. The consequences of inaction, well, it's we have a collision, a slow motion train wreck between industrial civilization and the biosphere. December last year, there was the Committee of Principles 30 meeting in Brazil, and the climate secretary said, COP30 showed that climate cooperation is alive and kicking, keeping humanity in the fight for a livable planet with a firm resolve to keep 1.5 degrees within reach. Well, I think that's pure fantasy on his part. We've already gone past the 1.5 degrees. Doesn't mean it should be abandoned. I think anything you can do to try and slow things down. But the problem is generated by the carbon footprint, and these problems would include significant weather events, storms, fires, droughts, sea level rise, it's accelerating at the moment, ocean acidification, that is can block the marine creatures that build shells. They are not able to survive, do their job. The death of coral reefs. The coral reefs are staggering along at the moment, but in 10 years' time, I don't know. The spread of viruses, infectious diseases, water depletion, and the ice fields that are being depleted, Himalayas, Greenland, West Antarctic, biodiversity loss, soil depletion. All of these things are going on at the moment, not getting a huge amount of attention, and it's exacerbated by the human population spiking up towards 10 billion. Labor still pays lip service to net zero carbon, and we're also committed to reducing climate pollution to 43% of 205 levels by 2030. This year we have to submit a new 235 target, and the Climate Authority says if you're going to the target for 2035 has to be zero if you're going to have any hope of keeping global warming below 2 degrees. Murray Watt certainly doesn't see this as an urgent problem. I think rather than doing something, there's a commitment to have done something in 10 or 25 years' time. Also, these commitments to reduce Australian emissions apply only to fossil fuels we burn locally. The coal gas we dig up and ship overseas and give away pollutes the atmosphere just as much as it would if it were burned here. Well, another way net zero carbon monies the water is you can balance emissions with carbon offsets, planting trees and so forth, which mostly turn out to be a way of fudging and cheating the system. Well, we're all fossil carbon junkies. Last week, the Crisafulli government approved an extension of Glencore's Hale Creek coal mine. Hale Creek produces about 1% of Australian coal and 20% of its coal mine methane. Methane is a greenhouse gas 80 times more potent than CO2. The mine extension will also bulldoze a nationally significant koala habitat. But Glencore says they are going to continue to manage and reduce greenhouse emissions in compliance with the National Safeguard Mechanism. In other words, paying some kind of attention to the offsets. And it adds it's implementing a greenhouse gas abatement plan, undertaking a gas pre-drainage study, and conducting ongoing reviews. So they're conducting studies and reviews, but not doing very much. At the time of the Hale Creek carbon bomb was approved, record floods were devastating nearby Bundaberg, and nobody seems to connect these two things at all. Well, we have oil, 100 million barrels per day that deliver much of our global energy consumption, and the 800 billion humans working an 8-hour day means that each of us has 100 fossil fuel slaves. Mind you, they're not distributed terribly evenly. I think if you're in Nepal or Bangladesh, you don't get as many as if you're in one of the more developed countries. Fossil carbon delivers or seems to deliver abundant, cheap energy, and certainly there are very real profits taken by the neoliberal oil barons. But we do collectively pay a cost for our carbon habits through higher insurance premiums for fire, flood and storm damage and other inconveniences. But the cost that we pay is nothing like the cost that will be paid by future generations that will be orders of magnitude higher. Well, energy, the basic driver of global warming, which is degrading the capacity of the biosphere. Population size is an important factor determining environmental impact. The Ehrlichs and John Holdren, way back in the 70s, put forward a formula to frame environmental impacts, the IPAC formula. Impact is a combination of population, affluence, and technology. I think it can be simply just roll together technology and affluence and think of the environmental impact as a combination of the population and its carbon footprint. Well as smaller footprints, which are certainly important, it would help if we had fewer feet. This is a familiar diagram of world population over the last 10,000 years or so. And it's the 20th century when things really start to take off. I put a dot in there for 1945 because that's the year that I was born, and world population has trebled in my lifetime. The dismal parson Thomas Malthus famously proposed that there were planetary limits way back in 1798. Well, he was wrong when the population doubled from 750 million to 1.5 billion over 140 years up to 1890. Wrong again when the population doubled from 1.5 to 3 billion. Still wrong when the population doubled from 3 to 6 billion, this time in 40 years. But will Malthus still be wrong 50 years from now? Well, zero population growth has to happen. World population at the moment is increasing at about less than 1% a year. And the population, according to Wiki, it's about 8.2 billion. If it were to continue at this rate of expansion, it would reach a population density of 1 person per square metre for the dry land surface in 780 years. I have to say I've cheated here. That was based on a population rate of growth of 1.3%, but it's not going to affect the argument at all. It's just a reductio argument. It just means it would take a few more years. It says, and the mass of people would equal the mass of the Earth in 2,400 years. So net zero population will happen. That is, the number of deaths will be equal to or greater than the number of births. The only question is how. And the same is true of net zero carbon. That's going to happen as well, either by things that we do cooperatively to bring it down, or if we just let it go and eventually probably all the coal mines will just get flooded. The planet that emerges from climate catastrophe will have significant reduced carrying capacity. James Hansen, one of the very early voices, still active, and he's got a nice website and keeping up the task of trying to get attention to a serious problem. Climate's at or near or at critical tipping points, and we do need to do something fairly quickly. One of the threats which is lurking is the melting of the West Antarctic ice sheet, which would probably raise sea level by 4 or 5 meters. Greenland, similarly, it would probably about 6 meters. So that has been projected as a possibility 1 or 2 centuries ahead, but the time frame for this seems to be progressively reduced as the years roll by. With warming, the heat gets disproportionately concentrated. Well, it's not concentrated. I mean, this is just evening out the temperatures, but if it's half a degree at the equator, it's about 6 degrees at with the Arctic. And the Arctic looks as though it will be ice-free within probably 5 or 10 years. And that introduces one of the feedback mechanisms, because the ice is a good reflector of incoming solar radiation. Once the ice goes, then heat can be absorbed easily by the ocean. And as that is absorbed, then it makes it more difficult for the ice to form. So it's a positive feedback loop there. Another worry is the Tibetan Plateau, which is the source, the Himalayan ice's source for 5 or 6 major river systems that feed about 3 billion people around China, India, and the associated countries. This is a slide that I plucked about 10 years ago. I was intrigued that the Bureau of Meteorology had introduced a new colour, the purple colour, for the temperatures up to 54 degrees Celsius. So that temperatures above about 37 get seriously dangerous. Once the temperature outside is above your body temperature, then you need to take evasive action, because you can get, well, it can kill you. So fossil carbon has improved our lives in lots of ways, and we could have continued it more or less indefinitely if only we'd paid respect to the capacity of the carbon sinks that Gaia has. Gaia can handle about 100 million tonnes of greenhouse gases per year, but not 35,000 million tonnes, which is what is being fed in at the moment. When carbon sinks don't cope, then the greenhouse gases, they turn up the thermostat, raising temperature to a higher thermal equilibrium, and each degree makes an enormous difference. Not likely to produce the Venus Express, that is an unstoppable rise, but there will be serious consequences. And it seems that after only 14,000 years, Gaia's most recent interglacial equilibrium is ending. And with sea level rises, lower latitudes will become uninhabitable, and the carrying capacity will be drastically reduced. So there's unlikely to be a soft landing. Here's a statement from George Monbiot about the problem. The power accumulated by fossil fuel companies through 50 years of plunder has enabled them to make stupendous profits, a staggering 2.8 billion a day on average in that period. They need to invest only a fraction to buy politicians and policies, in some cases political systems. And maybe that explains why the Labor Party is still subsidising the coal industry by $11 billion per year. But many people will have to move or die when the sea levels start to rise and the temperatures go up. Current global policies will result in maybe 2.7 degrees, and by 2000, and on that trajectory, probably 2 billion people will be stranded in inhospitable condition. These figures don't take account of rising sea levels. So we're witnessing breakdown of life support systems driven by neo-capitalism. Sure. Okay, some groups do take global warming very seriously. The military do, insurance companies do, and actuaries do. They absolutely get it right. But the Albanese government also commissioned a risk assessment from the Office of National Intelligence when it came to power, and the report was submitted in December 2022, and it's never been released. There's only a handful of crossbenchers have been briefed. One of these, the only one I know of who's spoken up, David Pocock, said that the contents of the assessment were frankly terrifying. And I think it's easy to understand probably what, if it's telling it as it is, probably be projecting forward about 20 years and saying that a lot of northern Australia will be effectively uninhabitable. How do people mostly respond to these facts? Well, most people, Bendel says, have one of four reactions. Well, one is, well, we still have time. It's not too bad yet. We can look outside and there are green things growing. And second response, well, technology will fix it somehow. Technology is really clever. Maybe we can develop mechanical devices that will take the carbon dioxide out of the atmosphere. And no doubt such devices could be devised. But when you think about it, taking the carbon dioxide out of the atmosphere is going to require more energy than the energy that was delivered by the coal when it went out. So it's much more prudent to not produce the carbon dioxide in the first place. Third reaction, and this is not as unusual as it ought to be, is that it's all a hoax. And another one is people just saying, well, it's complicated, it's unclear, I don't really know, I don't really want to know, and I'm busy. So how does Bendel himself respond? Well, he calls his response one of critical wisdom, which is it sounds a little bit new age-ish. It's a combination of mindfulness, critical literacy, rationality, and intuition. With my bihemispheric interests, I interpret this mindfulness and intuition a kind of a immersive right hemisphere responsiveness to a problem, whereas critical literacy and rationality is a left hemisphere approach. So it's good to be using both sides. But why is there such spectacular lack of interest? That's what, if you seriously engage with the stuff, I find it very difficult not to conclude that there is compelling evidence that there's a very serious problem that will get a lot worse. And also, there seems to be an extraordinary lack of any interest in it. And that is a bit extraordinary. Bendel has got his suggestion why experts, activists, media and others marginalise the topic or shut it down. The siloed research that a lot of people have got a good grasp of one element of the problem, but they don't see the total picture. They don't connect all the dots. A normalcy bias, you want to kind of not go too far outside the mainstream, and the technological hubris that, we're very clever and we'll work something out. Another factor, this is my suggestion, but other people have made it as well, I would think. In fact, I'll quote a psychologist, it's a Pleistocene adapted brain that we have that is hair trigger responsive to immediate threats, but is inclined to disregard things that are of longer term consequence. Seize the day. And an example of this that I dug out was President Obama proposed way back in 2009, moving some inmates from Guantanamo Bay, Cuba, to a supermax prison which nobody had ever escaped from. And this was the enemy with the club threat that we've evolved to be alert to. So the Democrats and Republicans erupted with complete outrage, couldn't possibly do that. And contrast that with the reaction to global warming. We've got melting ice sheets and rising seas, and the Congress scrounges a narrow majority to pass a cap and trade system. Senate is hesitating. It's a complex issue full of trade-offs, doesn't activate any warning systems. What's important is what is important is threats that are dominant in our evolutionary history, and kinds of dangers that are most serious today, like climate change, can sneak in under the radar. Also, this is another suggestion I think I think looks plausible. in the left hemisphere's technologically fabricated world, we've become disconnected from nature, and we need to take corrective steps to correct this imbalance. And Bendel suggests that Indigenous cultures are less susceptible to the horrors of transactional industrial modernity. Anyway, Gaia will certainly survive our anthropogenic insults, but will take a long time to regain some of her former glory from the wreckage. Like all stars, the sun's going to burn hotter as it ages, about 6% hotter in 500 million years. Life should be still around then, but eventually it'll get sufficiently hot, probably 1 billion or 1.5 billion years, when life will struggle to survive at all. So eventually Gaia will be overwhelmed, but certainly not for hundreds of millions of years. And I think it's regrettable that it looks like human civilization can only share a tiny fraction of the journey. Well, we've managed to understand a bit of ourselves and the universe, and I think we're very lucky to be around at the only moment in human and possibly galactic history when it's possible to understand a little bit about size, age, structure of the universe, and the complicated bits of the universe that constitute ourselves. It's been a good party, and it seems a pity to call it a day. Human extinction is a topic that I thought I'd discuss, but I think I've run out of time. It is an interesting topic, actually. Derek Parfit's got some interesting arguments about extinction. He thinks that human extinction would be a bad thing. And I don't disagree with him. I think from my point of view, it certainly is, but it's a bad thing, not just from the point of view of individual humans, but from the point of view of the universe. And that I find intriguingly problematic. Anyway, I'll have to save that one for another time. And I may have already blown my time budget anyway. So I'll just conclude with reflections from two environmental thinkers. First of all, George Monbiot, who I've quoted already, on fossil fuels. They helped us to fight walls of horror never contemplated before, but they also reduced the need for war. For the first time in human history, last 200 years, indeed for the first time in biological history, there was a surplus of available energy. We could survive without having to fight someone for the resources needed. Our freedoms, comforts, prosperity are all products of fossil carbon, whose combustion creates the carbon dioxide which is responsible for global warming. Ours are the most fortunate generations that have ever lived, and we might be the most fortunate generations that ever will. We inhabit the brief historical interlude between ecological constraint and ecological catastrophe. And finally, the word solastalgia I dug out. This is a word that was coined a few years ago. It's kind of analogous to nostalgia, but it's different because nostalgia is a grief that we feel when we're separated from some place that's of deep importance to us. It's a spatial separation, but it's possible for us to get back to it. Solastalgia is where the separation is more serious. It's a metaphysical separation because what you are grieving about no longer exists. And so I'm usually reluctant to admit new words into my vocabulary. I think that they're only justified if the vocabulary doesn't already adequately cater for them. But I think there is room for solastalgia. And Bendel ends breaking together with an epigraph from one of his heroes, also one of my heroes, E.F. Schumacher, 50 years ago. Everywhere people ask, what can I actually do? Well, the answer is simple. We can, each of us, put our inner house in order. The guidance we need for this work can't be found in science or technology. The value which utterly depends on the ends they serve, they're purely instrumental, in other words, but it can be found in the traditional wisdom of mankind. So I wish you all the very best of luck in your pursuit of traditional wisdom, and that's it.
Recording.